Let's move back to presentation and start. In case if you have any question, please put your question in comment section. So as I said, the topic of today's lecture is Introduction to Medical Informatics Basics, and we have two main objectives: definition and some overview of areas of studying under medical informatics, and second, telemedicine as a practical example of one of the most prominent implementation of medical of information technologies in medicine area. When we will talk about medical informatics, we have to provide some definition about what is kind of scientific area, check relationship to other sciences and areas of activities, then look around for different aspects of medical information fields, and I will provide some definition about subfields of medical informatics, and finally about medical cybernetics. That's also an important area. So when we talk about, before we will talk about medical informatics, we have to remind for ourselves definition of what is informatics in general. Here is given relatively old but absolutely correct and still active definition what is informatics itself. So it's simple enough and easy enough for students to remembering. So we consider informatics as science and art that's turned data into information, and it's become extremely critical, especially recent decades when we have huge data, more and more every time, every year, months, day, more and more data to be generated. And we need to retrieve something meaningful from this data. And this meaningful is information. So informatics help us with this. And by gaining information from data, we have chance to later got some new knowledge and come to new understanding of our surroundings. So when we will talk about informatics, again, more comprehensive definition. So it's broader academic field, which provides human-computer interaction, information science, information technology, algorithm, social science. And here is we have a related scientific area as it was shown on the previous diagram, when we have, in addition to informatics in general, we have information science and computer science, which are working together with the same goal. And we have to understand that information science provide us with theoretical studying of processing, management, and retrieval of information. In fact, this steps, this definition, like processing, management, retrieving information, will be repeated many times in definition of different areas around informatics, medical informatics, etc. And also we have a computer science that study of complex system information computation, which is mathematics and so on. And the related definition of scientific area, it's information technology, which is study, design, development, implementation, support, or management of computer-based information system. So informatics, information science give us theoretical background. They are actually independent, in fact, of computer technologies. They born before computer ever had been built and made. Information science, information technology, in contrast, it's actually that area which are very familiar right now. We are utilized, we are using this, we are enjoying this, because information technology turns achievements, informatics, into practical things, in fact. So now about medical informatics. And I will make, first of all, some retrospective look into it to show how changed meanings of informatics 2 years. And first of all, we turn about 40 years back. and look at the time how scientists define informatics. I have to make the point that by that time, medical informatics had been in development for a few decades already. And by that time, we had already had many practical application of medical informatics, practical solution, medical information systems. It was already available a few generations of computer tomograph at that time. So we already had many practical appliances around medical informatics, but as a scientific area, it was still was seen as science of using system analytics tool to develop procedures, algorithms for management, process control, decision making, and scientific analysis, medical knowledge. So it was mostly pointed to theoretical data analysis of healthcare data. Yet another textbook, another author, same year, medical informatics comprised theoretical and practical aspects of information processing, communication based on knowledge and experience derived from process in medicine and healthcare. The only difference from previous definition, at least here, mentioned some practical aspects, but still we are talking about mostly theoretical data analysis and data processing. And where was the turning point? It was the end of 20th century. So look at this. Previous author, another textbook, just less than 15 years spaced. In medical informatics, we develop and assess methods and systems for the acquisition, processing, and interpretation of patient data. I made emphasis with help of knowledge that's obtained in scientific research. So actually, since of the end of the 20th century, it had been made a significant, crucial change in definition of medical informatics. It had been turned from purely academic discipline into second layer has been added, practical layer and emphasis on improvement of patient care. So medical informatics become patient-centric, become oriented toward particular patient needs. And since that point, actually, we have few updates in definition of medical informatics, but it's still remains to be defined more or less in this way. And in fact, right now, more often even another definition had been used. So we have another more general area of scientific studies and practical application. It's health informatics. So not only medical informatics, but first of all, we have to consider health informatics as most general scientific area of studies. And it's spoken about application of technology tools, information system in healthcare settings or context. Any kind of settings, any kind of context, even when I am delivering this lecture online for medical students. So we are already part of implementation participants, and we are implementing of health informatics process through distance education in medical area. So, and it's comprised by two components, I mean, health informatics, health information technology and health information management. When FAST provide us with some tools like computers, hardware, software, still software, it's tools, networking, programming, storage, security measures, etc. And information management actually give us system, theoretical approach for creating medical records, encoding medical documentation, like guidelines, policies, treatment plan. So all this here is on the system we understand, not computer system, but system of records, system of data processing, etc. Okay. few more definition from Medline in the modern, still active definition, interdisciplinary study of design, development, adoption, application, IT-based innovation in healthcare service delivery and management and training. So yet more or less most recent definition of both healthcare informatics and medical informatics. Healthcare could be seen actually here spoken about health informatics or biomedical informatics. In fact, it's not in all cases the same, and I will show this later. But anyway, it's possible to be seen this way. So I still will be spoken fast about health informatics. It's field of science and engineering that apply informatics field in medicine. This definition is simple, and okay, maybe favorable. And still, we are more interested in medical informatics itself. So we have to define it as spectrum of multidisciplinary fields that include study of the design, development, and application of computation innovation to improve healthcare. So here it is. I recommend for you to follow this pair of definition because that's their most recent. And here is with this Venn diagram with intersection of this scientific area, here is where we have place of health informatics, intersection of information science, which give us theoretical studying about manipulation data and information, computer science, which first of all also give us theoretical foundation for computer-based information system, and healthcare area, which give us data to be processed, analyzed, and managed. And now time to turn to the second question of the first part of the lecture, when we will talk about medical informatics as multidisciplinary studies. So actually we have it here again shown on the Venn diagram. For example, how we can got now different subsection of medical informatics, like medical informatics, biomedical informatics, and actually it's not full list. So depending of our primary goals of studying, depending of our activities, depending of data we are going to acquisition, manage, analyze, we are going to get into different areas of medical informatic activities and medical informatical specialties. In fact, when we will talk about classification of areas of medical informatics, you will be able to find different approaches, different structures, by using different sources, textbook, online articles, and so on. So this one I will not make any strong emphasis and talk that it's this classification better and this worse. It's not actually a problem. So here is we have two different examples how we can consider health informatics, which include medical informatics as subfields and further subdivided into clinical informatics, bioinformatics, or we have separated specialities like dental or nursing informatics or public health as part of general health informatics. Other sources placed medical specific particular areas of medical informatics fields under medical informatics, like this time nursing or dental informatics move under medical, not health informatics. So it's not actually a mistake, it's rather difference in viewpoints. In fact, for me, better representation of subfields of medical informatics shown here at this Venn diagram, when it's really depict and present nature of subfields like being interdisciplinary. And here is more or less clearly we can see medical informatics as subfields of general health care and clinicals as part of medical informatics, obviously. But when we will talk about other subfields, other specialities, they will every time cross given areas to outside, because all of these specialities more or less include clinical as well as non-clinical activities. Uh, and in this case, we have this um, cross-section, like take a look, obviously public health informatics covers some clinical activities contained definitionally our guidelines and so on, but also it's include question related, for example, diseases prevention, prophylactics, and so on. So we move into area of more general health informatics. So here is we have, it's literally multidisciplinary study. What is aspects of medical informatics fields? So here is we have actually these four aspects, not limited by given four activities. That's maybe only most prominent, most important. Moreover, in recent years, when we will, to be honest, we have to exchange first and second points, because studying of architecture, electronic medical records, and health information systems remain important, and despite many like huge number of practical systems already delivered, we just have only some shifting in studying. Instead of developing new architectures, we have to study approaches, for example, to establish interoperability between different type of medical records, electronic medical records, and so on. What is more major area of scientific activities? It's definitely studying under decision support system, artificial intelligence, and so on. So tools dedicated to assist, or even sometimes under specific circumstances, replace physician in decision-making process. In fact, all of this become possible because of next pair of informatics fields. To be able to deal with electronic medical records, we had some standardized data structures, and those structures comes from international standards, which is used in healthcare now, like DCOM for medical images or HL7 for electronic medical records. So as a result, we have chances to establish interoperability between different medical information systems right now. And to have these standards, we had developed different special things like controlled medical vocabularies, like SNOMED and so on. So more about this I will speak on separate lecture, but right now we have to understand that all these things are aspects of medical informatics field for study. In fact, we have much more. We have much more, and here is in given list. It's all with links, and when I will share link to presentation, you will be able to navigate this link. But again, even this link, it's not complete, not finalized, especially right now with intensification of studying in application of artificial intelligence in medicine. So all this studying dedicated to improve our knowledge base, improve this area in diagnostic therapy cycles shown at this, starting from center and the right and top corner of this chart. So it's dedicated to provide physician with comprehensive knowledge base, which is based on rules like literature, guidelines, textbooks, and etc. Things like this. But it also composed, also covered evidence-based medicine, or base of known cases with known outcome, which provide us with statistically based evidence for our decision-making process. And when physician interact with new patient, collect data about his health of study, he have to refer knowledge base and using it, if possible, through modern decision support system, etc., in order to get make some reasoning, to make some decision, create, establish diagnosis, create therapy plan, uplift for patient, and cycle has to be repeated again. So we again utilize knowledge base to verify results of our treatment and made some adjustments. And finally, when we complete with particular patient and when we got some new insight from this particular clinical case, it has to be also added to, by this arrow, added to general case base and extend our knowledge base with new knowledges. So all through modern achievements, information technologies. So what is actually, which kind of information system could help us with this? So first of all, observing patient, we can retrieve some quite number of data, and our capabilities to examine patient only grows and grows in recent decades with different laboratory information system, picture hearing communication system. We can collect and store information about examination, medical images, and so on. So all this data comprise our electronic medical records within clinical or hospital medical information systems. And what is the question for physician? It's to retrieve information from this data, to use it in decision-making process. So for probably not decades, but centuries, physician do it on his own by using own notation system, by using own skills and knowledge. Right now, intelligent medical information system could help, could make some insight about data collected and stored in EMR, and has to make decision-making process easier. So moreover, with development of clinical decision support system, expert system, and now like artificial intelligence augmented system, so all these achievements have dedicated to give physician more power in making diagnosis and creating therapy plan through different, again, capabilities, which is supported by modern medical information system. So finally, that plan has to be uploaded to patient, and we will repeat this cycle by collecting new data and improve our treatment plan. So we create personalized therapy plan by by utilizing achievements in information technologies. So just again added some few points like about progress or so, maybe not like just 50 years, more than 50 years ago, what do we have? It's like even before those definition of medical informatics I give for you. So here is example of existing like developing and building medical information system, in this case, London Hospital, which required, here is we talk about only delivering of storage, which required trucks and crane. And here is we have things like SD card and other storages right now, or visualization when we compare faster tempo of recorded X-ray on film and modern. Okay, here is, as nobody of us has three-dimensional screen, so have to just believe that I'm talking about usage of three-dimensional visualization, which is in fact still, because of our limitation right now, I mean, within this lecture, we have to use flat screen, not volumetric display, which is required actually to visualize this image. And things more or less little bit not changes for recent about 20 years, electronic medical records. So actually mostly the same during recent few decades, but the only changes it's possible to collect more and more data. Because more and more medical data now available in digital format. They born in digital format by origin. So what is similar for all this system? It's relatively high complexity. Again, we will have separate lectures on medical information system, but at this point it has to be obvious. All this application contain a lot of dialogues, windows, tables, controls, etc., because it's dedicated to collect and manage large amount of data, different type of data to combine, like text records about patient case with like medical images, signal recordings like ECG, EEG, and so on. So all these things has to be stored at once. And similar in this case for dentistry, a solution, or dedicated solution for processing medical images, which become possible through after development of modern computer tomography systems. Okay, now very quickly I will pass through a few definitions of the subfields of medical informatics. So first of all, of course, very relatively quickly, because as I already said, they are more or less the same, very similar, in fact. So when we talk about clinical informatics, we have to understand the combination of information science, computer science, clinical science, designed to assist in management and processing data, information, and knowledge to support practice and delivery of clinical care. So in fact, we are limited only by clinics. As consequences, we can use more enterprise-based solution, enterprise-based information system, biomedical informatics. Concerned with study and application of machine technology in computer science, as well as decision-making, human problem solving, cognitive science, etc., etc., in the practice of biomedical science, medicine, and healthcare. And bioinformatics actually has not to be confused with biomedical informatics. Bioinformatics, it's in fact a lot more related to biological studying, genetic studying, and so as well as computational biology infused techniques, including wise mathematics, informatics, statistics, computer science, artificial intelligence, chemistry, and so on, to solve biological problems. So in fact, we have to understand bioinformatics does not have relationship to clinical care. That's important. Okay, and here is we have place of our health informatics, biomedical, and bioinformatics, again shown with Venn diagram. Practically, we will concentrate in more or less in the left area between health and biomedical informatics. You will have, during practical classes, you will have some points related to like health information system, decision making, statistical analysis, computational analysis, and so on. In fact, in this course, we will almost has no any DL related to bioinformatics, except maybe a few medical images will come from that area, like this. So we will concentrate on left circle. Okay, public health informatics become more and more important in recent year, especially during and since COVID pandemic, and define a systematic application of information, computer science, technology, public health, policy research, learning, and so on. So really growth become huge during and since COVID pandemic, and it's tightly related to achievements in telemedicine, because in fact we have to understand telemedicine also as very closely related to public health informatic area. One of the practical, again, implementation of public health. So that's again this definition of nursing informatics, which is actually almost the same as other areas of medical informatics area. Okay, before we will move into some practical application related to telemedicine and so on, few words about cybernetics. Cybernetics and medical cybernetics. Which is, in fact, cybernetics right now give us major achievements in medical informatics area. They come not from medical informatics itself, but specifically from cybernetics, and actually achievement in artificial intelligence. They are more related to cybernetics than pure informatics. So cybernetics has to be defined as interdisciplinary study of structure of complex systems, especially communication process, control mechanism, feedback principles, and mostly related to control theory, study theory. If I would try simplify, we have to consider cybernetics as case when anything has been considered as some kind of system, which is actual content of system is unknown, and we have only some like surrounding interact with the system. So no matter is it we talk about human to computer interaction, human to human interaction, human to some technical device interaction. So any kind of, no matter it's biological system, social system, technical system, cybernetics consider it as system which has some input, and in order to answer of those input disturbance, it respond with some output. So this way we have let's say feedback, and so we can only set up some input, measure feedback, and based on this, we manage with this system. Okay, I already said system as control as concept. Let me discover basic principles. Application, as I already said, I already mentioned artificial intelligence. Of course, it's attempt to create self-sufficient robotics. Also, computer vision in meaning of identification of object which has been recorded by some visual devices. Control management system, and so on. So here is, I already said, about how any kind of system represented its cybernetics, and the major emphasis that we have no difference between biological cybernetics. So not we. Cybernetics have no difference between biological, social, and technical systems. In this case, no matter is it we study about how like our brain and muscles are involved in sensory action, like this one, touch something cold or hot and then take back our fingers and so on. Or is it we are talking about some mechanical system, how it's react for our input and so on. And medical cybernetics or application of cybernetics in biology, it's study of cybernetic system present in biological organism, focusing on how animals set up the environment, have information in form of genes passed from generation to generation. In fact, we are talking right now not about single area of studying, but multiply areas and medical cybernetics in only one in line of cybernetic related and medicine related disciplines, including bioengineering, biocybernetics, and so on. And of course, for us, it's more medical cybernetics is most important and most interesting in this field of application of cybernetics, such utilize concept of cybernetics to medical research and practice. So major topics on the medical cybernetics include system theory in medical science, or area of the search for and modeling physiological dynamics. So starting from how cell work, from cell level to tissue level to organ level, and even including entire body. Medical information communication theories, so it's actually describes signal process information storage in different physiological layers. Connectionism, which is actually it's give us many insight about how brain works, and actually outcome of connectionism, it's things we have to detail its artificial neural networks. And recently we got what most recent achievement, it's things like ChatGPT, because they are all large language models. They are based on artificial neural network theory and practical achievement. Okay, and medical decision theory. So we gather evidence based on foundation for decision making in clinical settings. Analyze with aspect. Here is with aspects of medical informatics. Here is we have to make a point about distinct between so-called already called traditional and new medical informatics. When new or medical informatics of information age, emphasis had been made on cybermedicine, telemedicine, prevention, prophylactics, self-care, and so on. Again, area become extremely important and actively processed since COVID pandemic. Before it, we are talking about traditional medical informatics, which is related to industrial age, medicine, and orientation providers, and so on. Actually, what I have to admit that when we talk about how many jobs now taken by information system, we have more and more shift in direction to increase level of automation, and you can observe this right now practically again, just simply how quickly and efficiently achievements of large language model like ChatGPT come into practice and become useful in different areas, including medicine, for example, to creating different statements, improving statements, formulating diagnosis, and like encompasses a sketch of treatment plan into full description and so on. So again, I have to draw one more line with even more steeper inclination and added the one more arrow here. So those already outdated. We are turning more into automation and less human activity. Okay, second part of lecture. I'm not sure how much time. 13 minutes. Okay, I think it's a bit short, but enough. A few words about telemedicine as practical application, maybe one of the prominent, very modern, and often widely spoken implementation of medical informatics. So definition, objectives, different types of system, surgery, not sure we will be able to cover. So first of all, definition what's telemedicine, obviously by the meaning of the word, usage of telecommunication information technology in order to provide clinical health care at a distance. And we have another term, telehealth, which is referred to clinical as well as non-clinical service involving medical education, administration, and research. So, in fact, by implementing medical education process, delivering election online, right now we are exactly here. We are implementing telehealth process right now. Okay. So objective telemedicine. When people have spoken about telemedicine, so first things that I imagine it's like televideo conference between physician or patient and physician. But again, they spoken about televideo conference. Of course, it's true implementation of telemedicine, but it's not necessary to be this way. Because first objective of telemedicine is transfer of all kind of medical information, data and information, of course, even data. So like text description, images, audio, video, text description as well, and support medical specialist collaboration process within clinics, hospital, physician, patient, and so on. Includes online as well as offline methodologies. So sorry, even sending email with description of clinical case and request about some advice, it will fulfill objectives of telemedicine. Making voice call like 50 years ago or even before to the doctor about some advice, urgent advice about what I'm going to do with something feeling ill, something feeling not well. So it's already fulfilling telemedicine objectives. That means, in fact, we had telemedicine had been implemented even before this term had been invented. So actually, as I already mentioned, of course, we got modern telemedicine starting from the beginning of 20th century with development of different telecommunication, radio, phone, then later major achievements had been achieved through development of space exploration programs with requirements of remote biomonitoring and performing some remote action. But even in ancient times, when it was possible to write some recipe for medicine on paper and send to nearby tribes, that was fulfilled first objective, transferring medical information. So again, it's born before this name appears. About classification, so it's depend to classification to medical activity, telemedicine areas and activities depend to different objectives and sources. For example, here is we have three major components. Like store and forward, which is required, acquisition medical data and transmission to a doctor for further assessment offline and creating some advice. Remote monitoring, which is enable medical staff to monitor patient remotely using various diagnostic device. As I said, it's routed from space medicine projects. And real time, of course, at last time it will be real time interaction between patient provider to include phone, starting from radio conversation, phone conversation, online communication, and so on. As a kind of classification by function, by scale, like, so different textbook you will find more definition, but as you can see by function we have among other consultation, control equipment, monitoring, telemetry, but we have also distance learning here. So of course, as I said, when we start talking about telemedicine, we imagine something like this, which is definitely a right application of telemedicine, but more efficient and really important example, it's like collecting data at any remote location, or under some dangerous conditions, so frontline, yet another example, and sending those data for remote consulting remote medical organization, for medical consulting staff to get some advice, recommendation, and even instruction what it has to be done. And really, we can use any communication capabilities we have. So here is, we are talking about real implementation of telemedicine. Again, in the past, it was important of having some dedicated telemedical system in our medical facility, which allowed to connect different or diagnostic devices, or communication system, or data acquisition device. Right now, it become less important. Honestly, it become much less important because even basic desktop, laptop, even mobile phone has more than enough computational communication capabilities to be used as a telemedical system core component. That's also most of diagnostic device already had native computer interfaces, and we can get all necessary data from hospital network, for example. So something like a more advanced solution. Here is, we have at right side consulting card, consulting console. Okay, as I'm a bit skeptical about such solution, but if we have enough funding, we can use it. Nice case for collaboration. But at the left side, we have a devices which actually could really save life, like portable telemedical diagnostic equipment, which could be used in emergency case in areas which suffer from, for example, some natural disasters, technical disasters, or could be used at front line and so on. So those really vital solution to collect patient data, and then it has to be sent, okay, if possible, to this consulting card, or even to conventional smartphone for physician to get some advice. Such as practically telemedical solution already available for ordinary peoples. There are many solutions to be used at home. And here is shown one of the practical solutions which could be brought. This solution for United States, but actually it's almost any country right now possible to make a solution like this. And here is we have combination of diagnostic equipment, central hub to transmit data, and even some kind of feedback possible, and physician capable to adjust medicine usage of medicine by using smart medical case or so. Well, definitely somebody have to fill this medicine here, but still. So as I mentioned, we have many devices available on market which could be used for home diagnostics, and conventional tablets, smartphones could be used as hubs to collect data from those diagnostic devices to benefits and for physician for review and analysis and make recommendation. And so in fact, and that's the photo at top right corner, we have a case of real teleconsultation when a physician, yes, they are available or video connection to their ward or probably intensive care unit, but at the same time, remote physician have access to electronic patient record, images, online monitoring of biosignals, and so on. So here is a real example of full-scale telemedical activities in modern time, which is already delivered to the practice. And here is yet another diagram which shows us how it's possible to, how home monitoring system could be built. So speaking, for example, about Ukraine, major difficulty is this area. Backbone network which have to be used for data storage and delivery. We have right now a national medical information system, but right now it's dedicated to be used by clinical medical professionals and so on, and ordinary peoples can't even send their monitoring results. So speaking about other components, everything already available. So sometimes it's question about only organization of data processing in proper way according to not only technical requirements, but according to like legal processing, legal requirements, legal demands, and so on. And recent decades, more and more mobile device become involved in the medical process for obvious reasons. So, for example, mobile ultrasound machines that's already available on market for more than 10 years already. Like other devices use typically, for example, use it for monitoring ECG, heart rate, and so on, or like solution to turn camera into microscope or so. Actually, in the recent, probably 10 years or so, we have even further motion and further shifting into different wearable device, usage of wearable device, embedding diagnostic sensor into like different, into watches, smart watches, wrists, literally even into imprinting into clothes and so on. I'm not speaking about biological implants because they require surgery to be injected. Here I'm talking only about so-called wearable devices. The only, in fact, limitation when you have to keep in mind, actually, we are already out of time. The only, in fact, limitation, it's legal notice. So here is slide from COVID time. And here is, you see, that's only about few devices had been listed there as diagnostical devices. So most of devices from previous slide, they are not a medical equipment. They have capabilities for recording different different vital signs parameters of human body, but officially, legally, they are not diagnostic equipment. So here is the things we have to keep in mind. Okay, I think we are run out of time. This topic you have to process on your own. Thank you for your attention.